Hello, my name is Sneh Pandya, and I'm very excited today to talk about our recent work, AGNet Weighing Black Holes with Machine Learning. This work was done with the contributions of my team, Joshua Yao Yu Lin, Devanshi Pratap, Xin Liu, and Matthias Carrasco-Keen. This work was done at the University of Illinois at Urbana-Champaign with support from the National Center for Supercomputing Applications. So our story starts with active galactic nuclei, otherwise known as AGN. So AGN are the most compact luminous objects in the universe, and the luminosity of these objects is understood to be caused by the accretion of hot matter as it falls onto supermassive black holes. So supermassive black holes typically have masses greater than 10 to the 6 times the mass of our own sun, so very large masses. And measuring AGN supermassive black hole mass is important for understanding the origin and evolution of supermassive black holes, notably the relationship to their host galaxies. The data we use in our AGNet implementation are AGN light curves. So traditionally, estimating AGN supermassive black hole mass would require data that is much more expensive and data from other surveys, notably full atomic spectra, which are much more robust than just light curves. However, in the future, a much more efficient approach will be needed in the era of the Vera Rubin Observatory, specifically the legacy survey of space and time within the VRO, which is estimated to observe over 10 million possible AGN candidates. So our AGNet pipeline is shown here with 2 possible routes in predicting supermassive black hole mass. In the case that spectroscopic redshift for an AGN candidate is not available, we start with quasar light curves in the UGRIS bands from Stripe 82, and we pre-process this data, notably computing the colors for our associated bands, because these are much more robust indicators of the AGN's underlying spectral energy distribution. We feed this into our feed-forward neural network and predict AGN redshift, which we denote here as Z star. In the case that spectroscopic Z is available, we skip the Z prediction and match our quasar light curves with additional Stripe 82 data, the DR7 catalog from which we obtain our ground truth mass estimates, and the damp random walk from which we pull additional time series features. We do additional pre-processing and feed into a feed-forward neural network, train and estimate supermassive black hole mass. In the future, further testing with the dark energy survey supernova fields and eventually the legacy survey of space and time would be beneficial. So on the left here are our AGNet results for predicting redshift, and on the right here are AGNet results for predicting mass. You can see that our model performs exceptionally well in predicting redshift. We do notice considerable deviation for predictions for Z less than 2. However, this is well understood and something we expected going into the project. This is basically caused by degeneracies in the colors of our quasars. On the right here are our mass results, and you can see that there's considerable more scatter in our mass results. However, we do achieve a root mean squared error of 0.3574 and a Pearson correlation coefficient of 0.6549. For context, our uncertainty in our results is already comparable to the systemic uncertainty in our ground truth mass. We additionally compare our AGNet pipeline with traditional machine learning means, in this case, a k-nearest neighbors algorithm. We can see from our data that our AGNet pipeline performs better than traditional machine learning, and the nonlinearity that we hypothesize exists in our light curves, which encodes the information of our mass, requires more sophisticated neural network architectures than just traditional machine learning. So in this work, we've shown that it's possible to estimate AGN supermassive black hole mass from just photometric light curves with neural networks. This QR code on the right will take you to our archive paper. Thank you for listening, and please do not hesitate to reach out to us with any comments or questions. Thank you.